all the things. So it's really all on you to ask and advocate for yourself instead of like sitting around having a. Okay, so moving forward, unit 3. First thing we're going to talk about is scatter plots and line of best fit. So the first blank that we're going to fill in, a scatter plot is a graph in which the values of two variables are plotted along two axes. The points do not connect. The pattern of the resulting points reveals any correlation present. Okay. So we use the word correlation in everyday language. So what's another word for correlation? Close your room, like turn your ring. Really flipped it. Don't open it again. It's nice. What's another word for correlation? Match, other words. Seem alike. What else? Like if I said there's no correlation there, what am I saying? Right? They have nothing to do with each other. No, they're not. They're not what? Nothing in common. They don't have a relationship if there's no correlation. So relationship, association is all correlation. So like just another word for it. If I said there is a correlation, then those values do have a relationship, or at least on a scatter plot, it looks like they do. So a correlation is the measure of a linear relationship between two quantitative variables. I've opened. There is positive correlation, negative correlation, and no correlation. So we're going to sketch some scatter plots that would apply to each. This would be an example of a positive correlation. Why? Because it's going up from left to right, like how you read. Kind of like our slope. Like if our slope is going up, the line is going up, then it's a positive slope. So the correlation kind of goes with that. So then if it's a negative correlation, it's going to be going downward. And it doesn't have to be like a perfect straight line. I just have to be able to tell that like as the x is increasing, the y's tend to decrease. So like there could be some outliers, so to speak, or some things that go against what the trend is. That's why like data isn't always perfect straight lines. But if you can't tell whether it's going up or down, then that would be like a no correlation situation. Like this. I can't tell it's going up or down. Another no correlation situation would be like if they're all in the same value. Probably more course, but it's like either all in the same value, no like change, or you just can't tell if it's going up or down. So that would be our no correlation. So one way to quantify the correlation of a data set is with the correlation coefficient. Denoted by R. So we'll call it either correlation coefficient or we'll call it the R value. I don't remember which one is on your test. Be prepared for both to be on your test. They mean the same thing though. So that's a way to quantify the correlation of a data set. I could put it into technology and have it tell me what the R value is, which is the correlation coefficient. It varies from -1 to 1. with the sign of the value corresponding to the type of correlation, positive or negative. So if, you know, the R value is positive, then I know on the graph, it looks like as X is going up, so is the Y. If it's negative, it's going down. And remember, like, there's a bunch of numbers in between -1 and 1. Like there's a bunch of decimals in between. So it goes from -1 to +1. Strongly correlated data points look more like points that lie in a straight line and have values of R closer to 1 or -1. Weakly correlated data will have values closer to 0. Okay, so to kind of illustrate that, there's a question of like R value strength is going to be on your test. These are what my R values go between and every decimal in between. So like I could have a 0.5 here. I could also have a -0.5 here. But the strongest need the most linear graphs are going to be when it's 1 exactly and -1 exactly, or really close to it. Then the next strongest will be like maybe on the way there. The weakest would be in the middle, closer to 0. So that's what we mean by like if it's closer to 0 or 1 or -1, like opposite directions. The weakest is in the middle. And then the strongest is on the ends. Okay. So really, when we're having you rank strongest to weakest R values, the sign has nothing to do with it. So like the sign just tells you if it's going up or down. It can be strong and go up, and it can be strong and go down. Strength is like how linear it is. So to add on to that, we're going to say when the absolute value of R is closer to 1, I'll just put it's close to 1, it is strong. So when the absolute value of R is close to 1, it is strong. But you may or may not be familiar with absolute value. What's the absolute value of, so I'm just gonna, it says nothing to do with R value, so I gotta never do with that. Well, what's the absolute value of 5? Not -5. How far is 5 away from 0? 5. What's the absolute value of -5? So when we're talking about R values, and we're saying like when the absolute value is closer to 1, the absolute value of -1 is 1. So that's ignore the negative, but the ones that would be like closest to 1 for the absolute value as highest. So this is just an example of absolute value. These straight lines, kind of like parentheses, but they're straight lines, are absolute values. So we just say how far is this number away from here. Okay. So first thing you're going to try, you have 4 scatter plots. You also have what's called a line of fit drawn in the middle of them. We'll talk about line of fit more in a little bit. But just based on our discussion of R values, correlation coefficients, first tell me for each scatter plot, is it strong or weak, positive or negative? And then tell me what R value it would be closest to out of these 5 options. Give me like 3 minutes to do that. I will call in. Strong, do you know why? Or just look a guess? Because they're close together. Good. So the more in a straight line they are, the stronger it is. So the first one we would say is strong. Now the strength has nothing to do whether we classify it as positive or negative. So Gianni, would we say that this one is positive or negative? Negative, because as the X is increasing, the Y is decreasing. So we classify this as a strong negative correlation. So if that's how we're classifying it, Logan S, what type of R value would it be closest to out of these options? Okay, let's work with it. Which ones can it not be? If it's a strong negative. Okay. Now we're down to 4. If it's a strong negative, which ones can it not be? So now we're 50-50, knowing that -1 is the strongest. -0.5 is like in the middle between weak and strong. What would you say this one is closer to? Go ahead and say, if you have to guess, would you say this one is closer to -1 or -0.5? It's not labeled, so I couldn't tell you what about it. But just for how close it is to the line, closer to -1. It's what I would go with. As long as you're definitely not saying these other 3, because it cannot be those other 3 if it's going down. Yes. So -0.5 is like right in the middle of strong and weak. So that would kind of tell me like they're not going to be necessarily close to the line, but I could also tell that it has a pattern, like it's going down. Does that make sense? Yeah, like loosely around the line. This, I mean, a perfect -1 would probably look more like this. But data is not often perfect, so we're just saying what is close. That's all you have. Questions on that? Okay. So Layla, the one that's right next to it, would you say that this is strong or weak? Strong, do you know why? Okay. Can someone help her out? It is strong, but why is it strong? Dots are close together, forming a straight line. I mean, it's not perfectly straight, but you can tell, like, there's a line that's drawn in the middle of them. It's mostly straight. So we'd say it's strong. Hannah, would you say that this is positive or negative? Good. So whether it's positive or negative should tell you, like, is it going up or down over time? So we'd say this is our strong positive correlation. And if that's the case, Natalia, which R value would it be closer to? 1 is correct. So the positive one. If it's strong, we expect it to be close to 1. If it's positive, again, close to 1. Good questions. So then, Lakeland, bottom left, would we say that that one is strong or weak? So that's weak, especially if you compare it to the one above it. We'll be ranking some based on like strong or weaker here later today. But this one I would say out of the 4 is weak. Gunnar, would you say that it's positive or negative? Negative because it's going down. Like our slope. Weak negative correlation, which means we'd expect the R value is closer to what out of the 5 options? Negative 0.5 out of 3. Because if we said 0, that would be like, I can't even tell it's going down. And this one, you can tell it's going down, but it's definitely not as strong as the one above it, but closer to negative. Angela, what about the one to the right? Okay, good. Give me all of them. So weak positive correlation. And R value closer to positive 0.5. Because again, if you tell it's positive, like it's going up, closer to 0 would be like we can't even tell if it's going up or down. But it's definitely not as strong as the one above it. Questions on vocabulary for R value and correlation coefficient. Okay, so backside, some more vocabulary before we start doing some calculations. So a line of best fits / linear model, we can call them all sorts of things. Linear models, linear regressions, trend lines, line of best fits. It's a line that's drawn through a set of 2 variable data that illustrates the correlation. So just like you saw a line drawn on those first 4 scatter plots, that is a line of best fit. When there is a strong correlation between the 2 variables in a set of 2 variable data, you can use a line of fit as a basis to construct a linear model for the data. So like, I can use it to answer other questions that I didn't necessarily gather in an experiment and survey. This is what we did a lot in college. So like these black dots could be like something that I gathered in an experiment or something. And then the line I would generate with the computer, and whatever equation went with that line, I would use it to answer other questions. So like, based on the model, what would be average annual temperature when the latitude is 40? And I would use the equation to answer that. Or maybe something that's like way off the graph. So you will be doing some of that too, like plugging in, and so I'll be kind of that on one of the worksheets already. But let's see where we're at. When estimating the line of fit, you are going to draw the line that the data points appear to be clustered around. It is not important that any of the data points actually touch the line. Instead, the line should be drawn as straight as possible and should go through the center of the scattered points. You want your line to be drawn above all the points, below all the points. Let's open our eyes. You want it to be drawn through the center of the points, down the middle. So if it were me, because I mean, you won't have to do a whole lot of it by hand. I mean, you do have it on your final, and your final's on paper. But if it were me, I would line up my piece of paper to where it looks like it's going through the middle of my data points and draw as straight of a line as possible. Keep it perfectly straight line. Like this. And then once a line has been drawn onto the scatter plot, you can choose 2 points on the line to write an equation for the line. So this here on the graph, drawn for you already, the line that that's fit. What type of function is it if it's a straight line? Linear. What's the equation for linear functions? Like the general equation for anything that's a straight line? Okay, good. And in y equals mx plus b, what are the two things that are usually replaced with numbers? M and b. So that's why these steps are the steps that they are. Because if I'm going to make a linear model of the line, I need to estimate the slope and the y-intercept. Okay, and then we're going to estimate it. And then we're going to show you how to do it with technology. So first step, you're going to identify 2 points that appear to be on the line. So it does not have to be a data point. In fact, none of these data points are perfectly centered on the line, right? So I'm not going to pick a data point. I'm going to pick where I think that the line goes right through the little crosshair. Like that would be a perfect one to pick. Because I don't have to estimate what that intersection is. I can just read the graph and it'll tell me. Guys, I need you to sit all the way up and open your eyes on the screen. Like I'm demonstrating for you, and it'd be nice if you look. Kyle, I need you to look, the very minimum. Okay. So we need to identify 2 points that appear to be on the line. So here's one point that I think looks like is easy to see. It's on the line. I don't have to estimate it. That coordinate is 60, 40. Right? Everyone see that? 60 for the X, 40 for the Y. It wasn't a data point. It's just something that I could see on the line that I don't have to like think too hard about with it. You yourself look at your paper, don't say it out loud. There's a few different other ones that you could see easily. Find just one other one that you could see without having to estimate. Look on your paper, find another point that you don't have to estimate that is just right on the line. Okay, Kathleen, did you find one? There's 90, so let's see. 30, 90, I'm getting that over here. Okay. I heard something, but what did I hear? I think it's 15, 90, in right there. Everyone see that? 15 here because that's between 10 and 20. And then 90 to the left. You could pick other points, like does anyone want to see if their point is on the line? 40 works, or actually that looks like 45. You did 55, 45, you could do that. But all I need are 2 points that appear to be on the line. And I'm gonna do these 2. Okay, but as long as it's on the line, then you're set. So identify 2 points that appear to be on the line. Next, I'm going to calculate the slope. Slope, you can think of a lot of different ways. Rise over run, change in y divided by change in x. this formula I'm about to show you is probably the most important one. Because it's the same for your average rate of change that we're going to talk about. So to calculate slope, use y2 minus y1 over x2 minus x1. And to do that, you just, of your two coordinates, pick one of them to be x1, y1, the other one to be x2, y2, and then plug it into your formula itself. So when I plug it into my formula, I'm saying that my y2 is 90, my y1 is 40, that's why I don't skip the labeling step, y2 minus y1, over 50 minus 60, x2 minus x. You could use Desmos for this if you're using it though, maybe like put the parentheses around the numerator and then around the denominator, so it's a piece of right. But 90 minus 40 is 50. 15 minus 60 is negative 45. And then I'm going to divide those. So 50 divided by negative 45 is negative 1.1 repeat. We'll just round it to negative 1. So now, depending on what points you pick, there could be some variation, but like, and if this was multiple choice, I would want to make sure I'm picking the one that has a slope of closer to negative 1. Does that make sense? It's not going to probably be exact. It'll just be close. All right, so that's just the slope. In slope-intercept form, we usually have something for the b. Now, if you can see the y-intercept on your graph, just estimate it from looking at your graph. I can't see it right now. So I'm going to follow this step for how to solve for it by plugging in the y, m, and x into y equals mx plus b. So the m we just calculated as negative 1.1. The x and y we can get from one of the things we plugged in. So say we want to choose, let's do 60-40. I like the numbers a bit better. That would be 40 for the y, 60 for the x, and then plus b, we're solving for b. So on the left, it's still 40 on the right. I need to do negative 1.1 times 60. And that's 66, or negative 66. And get the b alone. How do you cancel out the negative 66? By adding 66 to both sides. So here to cancel it out, on the left to keep it equal. So I get that my left side is 104. Or 106 actually. It's 40 over 66, so 6. And it's equal to b, because now we got the b along. So slope was negative 1.1, y-intercept is about 106. Writing it in slope-intercept form looks like this. Now, if this was a multiple choice test, which your final, for the most part, is, I might not see this exact answer, but I pick the one that has it close to it. So slope close to negative 1.1 and a slope close to 106. For reference, earlier we did 2 different points and we got this equation, negative 1x plus 100. Is it not pretty close to what we have in here? It's not going to be perfect unless we're using technology and we can see every single that. All right, questions? Okay, I'm gonna have you try that for the one that says your turn. So follow those steps. I'll leave it showing all the steps. So first, identify 2 points that appear to be on the line. Calculate the slope. Find the y-intercepts, but see it on the graph and just use that. Write the equation in slope-intercept form. Give you like 3 to 5 minutes to try that one before I show you how to do it. Okay. So I asked you guys to estimate the line of fit for this one. First thing, if you're doing it by hand, is to pick 2 points that appear to be on the line. Does not have to be a data point. However, all of these data points do look close to the line. Only maybe like 1 or 2 of them are perfectly centered on the line. So like this one looks like a little good. Maybe it's like above it a little, but the line where it actually is, we really good jobs. So like maybe I would have picked 5, 10. You don't have to erase your points if you pick different ones. But then another one that looks kind of close. Maybe this one. This is like it's touching right there. Like 0 to it. It could be. Yeah. So it just has to be on the line that's drawn. Does not have to be an actual data point. These 2 areas I picked happen to be near data points, but we're picking based off of the line. Does anyone have any others that they think are on the line? Or 8? Or 8, the line looks like a little bit above it. So maybe just to make it a bit better, maybe I'd pick like 8.1. But it's not, like it's close. Whatever points you do pick, even if they're all perfectly on the line, our estimates will probably be different from each other. So at the end of the day, it just has to be close. So I'm going to pick the 2 that I picked in green. You do not have to erase yours. See what your final answer is, how close it is. Once you pick your 2 points that appear to be on the line, label one of them as x1, y1, the other as x2, y2, and plug it into your slope formula, which will, you'll want to really remember this formula because we use it all the time throughout the rest of high school. It's your average rate. It's like on every test. So y2 minus y1, I'd be doing 10 minus 2 over 5 minus 0. Calculator if you need to. 10 minus 2 is 8, 5 minus 0 is 5. When I divide those for my slope, $1.6. Thank you.
It doesn't matter which one's
It doesn't matter. I could switch these. The only thing you can't switch is like, I don't know, you can't make this one X1 and this one Y1. Like it has to be from the same point. When I set it up in my formula, it should be that the numbers from the same coordinate are on top of each other. With the Y always being the one that's on top. It's like right with the, you know what I mean? Is it close to mine? We'll see why. They went for it a little too high, see? Like it's not on the line. And I mean 3.7, I would think is a good one to play, but that could be why it's a little off. I don't know if you did your math right or wrong, because I didn't do it, but it should be something close to 1.6. Questions? I mean, 3.5 is still pretty close to 1.6. All right, so that's my slope. that would be this part of my equation. I need my y-intercept. Now, if I have it graphed, I can just look at if it touches the y-axis. Can I see that on this graph? So what's my y-intercept approximately? 2. Raise up front. About 2. So I would even just go off and say that. However, if you couldn't see it or you forgot, oh, that's my y-intercept, you could do the plugging in. So 1.6 times x, let's take this one because those numbers work out nicer. Y is 2 plus b was 1.6 times 0. And then I get 2 equals b. Look up and then I'm going to calculate it. If I picked the other point just to show you, this one might be where I actually have to do a little bit more work. But 1.6 times 5 is 8. Plus b equals 10, subtract 8 on each side. Again, b is 2. But in a different class today, we did it by hand, and I don't think we got to it, we got like 2.2 or something similar. Maybe even like 1.9. But it just has to be close. If it's way off, like if your y-intercept is 10, clearly it's not 10 on this graph. Right? So that would be right. Wrong. Questions on what we just talked about? Okay, now I'm going to show you a technology. So I'm not necessarily going to write out the steps for you. If you want to write down some steps, go ahead, because during the quiz, I can't help you with your technology. But the good thing about this example is it gives you a table of values. Whenever they do that, it makes it so much easier to use technology. I'd probably actually just do that because it's always the most accurate anyway. And this is how you do that. You press this button that says add item, and we're going to add in a table, and you're going to transfer your data from your table to this table in Desmos, exactly how they give it to you. Don't mix up the coordinates because then that would make it wrong. Don't leave any coordinates off. You want all of your data. You could see it starts plotting it. And in a different cell, you're going to click and you're going to type this formula. So it's going to be y1 squiggly line. Y, we pay attention. X1 plus b. So it's like y equals mx plus b, except for if I want it to attach to this table, I have to like use what they have. In another class, someone might have like, I don't know, put too many tables in here. And so it said like x2, y2. So we just changed it back to x1, y1 so that it attaches to this. And then the squiggly line you can find above, well, underneath the escape button on your keyboard. So hit shift, find the squiggly line. Don't forget the plus B so that it's making a linear model. And you could see it draws it through the middle of the data where the points seem to be clustered around it. And look at all this stuff it gives you. It gives you an estimation for the slope and for the y-intercept. So if I was using the technology from the beginning, then I would tell you that this is the best linear model. It would be like 1.5x approximately plus 2.3. Does that make sense? Okay, well, I hope we're paying attention because that's what you need to do on your final. I tried doing the one on your final by hand and I found that I was stuck between like two answers. So just doing it with the technology will always give you the best answer. And then you just pick out of your options which one best matches it. Other things it shows you on here are
I mean, we don't deal with R squared in ninth grade, but the R value we've been talking about a lot today. That's your correlation coefficient. Would you say that this data is strong? Yes, because this is close to what? 1. Would you say that it's positive or negative? Positive. Without even looking at the graph, if I just had the R value, that's a positive number, so it's a positive correlation. So if you ever needed to calculate R value, you'd plug in a table and do that. Now, because your practice is not a worksheet today, it's going to be on Schoology. I just want you to know, like, let's look at the last your turn. If this was me, because you can't draw a line on your computer, right, to see where it touches the grid lines and things, because you can't do that, I would recommend make a table of values by estimating the dots. So like on this next year turn that I'm gonna have you do, that first dot is 21,170 approximately. Next dot, 22,160. 22,169. 24,135. Like, does everyone see like where I'm getting these numbers? Do we know how to read a coordinate plane? That's what I would even recommend you do on your test to kind of make your life a little easier. So yeah, once you make your table of values, plug it into Desmos, just like how I showed you, and tell me what the best linear model would be. Okay, and these are my estimations from where the dots are, not from the line, because you can't draw on your computer screen, right? This is what I do for my homework and for the quiz. So find the line of best fit for this one. This will be the last you try. When and if you finish before we go over it, work on your practice in Schoology. So tell me, like, I didn't already know how to plug this into Desmos. Caden, what do I have to press first? What'd you say? What do I press first? Okay. Okay. Wyatt, what do I press first? This plus sign. Not the one from this little keyboard down here. We want this plus sign that says add item when I hover over it. And what am I going to be adding? A table. This should say X1, Y1. If you put in multiple tables, then it'll probably change it to like X2, Y2. Just make it X1, Y1 to make it easier if it does change. And then you're transferring your data from the scatter plot onto your table. Don't leave any off. We're just kind of estimating it. So if you estimated some of them a little bit differently, that's fine as long as you know how to read and know what numbers it's between. It should be close. Okay, so there's my data. If I zoom out, I could see it plotted over here. In a different cell, I'm going to type in what'll make the line down the middle. So, Jenny, what do I need to type in here? Okay, good. So the little squigglies under the escape button, like hit shift, hold that button down till it makes it. It should generate some statistics right here, and it should make a line down the middle of your data. You literally just on your keyboard press Y1 and it'll automatically make it a subscript. Like you don't have to press anything fancy. Good question. Any other questions? Okay. So then it brings up all these statistics, including an estimation for the slope and the y-intercept. So if I was just using technology from the beginning, which will always give me the best fit line, then my model would be around negative 8.8 for the slope and near 356.2 for the y-intercept. Now, if it's a multiple choice test, I might not see this answer. I might see something that's close to it. So like maybe on the test, I have a couple that are close to the slope, but not the y-intercept. So this would be like a y-intercept that's way off. I wouldn't want to pick this as an answer. Maybe they have some where the slope is way off, like that, but the y-intercept is close. I want both things to be close. So like, I don't know, this is pretty close to this number, and maybe that. If these were my three options on a test, I'd pick the one that has the closest slope and y-intercept like together. Does that make sense? Like eliminate the ones that have things that are way off, like that y-intercept is way off, this slope is way off. This one's just right. It's close enough. Okay. So yeah, that's all I have for this notes. Your practice, I'll visually show you which ones you need to do because there's multiple things in there right now, but it's the ones that are right under the notes for today. And then if you have questions as you go, let me know. If you're still writing, I'm gonna switch this soon, so hold on.